So I want to welcome everyone to week 15 of xEssentials. Tonight's presentation is an exciting topic, one we've been looking forward to for a while. It's Dmx Fixtures, moving heads, fog, and snow machines. So Lee is an expert in this area and will be walking us through some of the basics and some of the advanced things that we need to do to get xLights to communicate with our fixtures. So Lee, you've got the floor. As he mentioned a few minutes ago, if you have any questions, you can either raise your hand, put it in chat, or interrupt him as you can. Thanks. Lee?
All right. Thanks, Ed. So this is Lee Lindquist. I've been building animated Christmas light shows, starting with lore since about 2007, and I've been using xLights for about 3 years now. And I've got a little bit of a, unique background or something that got me into this a little bit more. My sister has worked for a number of production companies and worked for Disney for several years doing some installs out in California, and really kind of piqued my interest. And I have to attribute some of my my knowledge and depth of understanding to her, because she comes from the theatrical side where it's big lighting consoles and lots of programming. And I'm totally from the DIY hobbyist side. So it's been neat to be able to bounce some things off of her. But just to start off with some of the basics, really, what is DMX? So DMX is an acronym that stands for Digital Multiplex. And basically what that means is to control lighting, there are multiple, basically just dimmers, or you can think of them like sliders in every lighting device. So on a pixel, we have 3 channels, red, green, and blue, and they all have individual intensities of, you can think of it as 0 to 100%, or in the digital binary world, it's 0 to 255. DMX is the original lighting communication protocol that was designed to run theatrical lighting fixtures, building lighting controls, and it has been extended and abstracted for use in a lot more dense applications like what we do with our lighting displays. So the original DMX communication was a 2 or 3, if you add the ground, 2-wire, basically differential signal that is a digital signal, and it works on a bus topology, which all that means is all of the devices are listening to the same data stream. So if you think about how pixels work, if you take one pixel, connect it to another pixel, connect it to a third pixel, each one of those pixels is pulling in its data. It is processing that data, consuming the data for it, and then regenerating that signal out to each one on the line. So the light that you see on each pixel is dependent on its position. If you take one pixel out and move that pixel to, if it's in position 1 and you move it down to position 50, that pixel is not going to have the information for position 1. It's going to have the information for position 50 because it's all based on where it is in the chain. DMX being a bus topology, each individual dimmer, each individual fixture, each individual channel is listening for a specific address. So if you plug all of the DMX fixtures into a single DMX universe, and I'll explain what a universe here is in a second, all of those fixtures are going to be listening to all of the same data. They all have access to all of the data on that wire, and they are going to pull off the data for their start channel. So going into what a universe is, before DMX was extended with things like E131 and ArtNet, DMX could only carry 512 channels or 512 dimmers worth of data per cable. That was the design of the protocol. And basically 1 cable's worth of data is 1 universe. So if you wanted to run more than 512 channels worth of data, you would use multiple cables. And so the fixtures on one universe would have no knowledge. They would have no information. They can't talk to each other at all across that universe. So that's kind of the boundary line. So if you had a fixture that was on universe 1, start channel 1, and you move that same fixture to universe 2, start channel 1, it is going to react with whatever data is on that universe and have no knowledge of the other one. So the DMX fixtures themselves don't have any knowledge of a universe. So to explain how some of the cabling works, because that's one of the common questions that I've seen is, hey, I've got this DMX fixture, this DMX floodlight. How do I actually connect it to my thing? So, oh, this isn't the portable props topic. This is DMX. All right. So this is a 3-pin XLR connector, which is your common DMX fixture connector. And to connect it to a controller, whether it's a Falcon controller, SAN devices, AlphaPix, anything, all of your Pixel controllers will have a DMX out port. And I wanted to kind of show you how that works. So all of your DMX cables at the end there will all be labeled. And unless they have been mislabeled, due to a die error, just a poor manufacturer, those pins 1, 2, and 3 are going to be standard across the entire industry. And that pin 1, pin 2, pin 3, that represents the actual data line all the way through the cable. So this is the female end that would be plugging into a fixture, and this is the male end that would come out of a fixture. The 1, 2, and 3, if you can see that on there, the 1, 2, and 3 numbers, the 1 will always match up to the 1, the 2 will match up to the 2, the 3 will match up to the 3. So you don't have to worry about like crossing them over to get from one to the other. It's always going to be straight through as far as the numbers are concerned. And on this cable, a 3-pin XLR is the most common cable that's out there, but it's technically not the cable specified in the standard. So there's a 3-pin XLR, which is what this is, and then there is a 5-pin XLR, which looks just like this, but it has 5 pins. The 3-pin is the most common just because it's cheaper to manufacture, and it's probably what you'll see on a lot of your moving heads, RGB, LED uplights, etc. The common wiring pattern is that pin 1 is the ground pin, pin 2 is the negative, and pin 3 is the positive. And in this one, the color scheme is not necessarily universal. So these are just cheap XLR cables that I got on Amazon. So on this cable, the red is actually connected to pin 2, which is the negative, and the blue is connected to pin 3, which is the positive. So on your Falcon controller, AlphaPix controller, SAN devices, any kind of controller that has a DMX output, and I'll go back to sharing my screen here because I want to show you the pin outs. So if you look, this is the Falcon manual. On DMX output 1, you can build your own RJ45 to XLR cable by just following this guide. So on a standard Cat5 cable with the standard wire color, your orange is going to be your output 1 data positive. Your orange with a stripe. Your orange solid is going to be your output 1 negative, and you just wire those colors to whatever color you have on your XLR cable, and that's how you make your Cat5 or RJ45 jack to XLR DMX cables. So it's pretty straightforward. Don't be intimidated. You just have to match the positive to the positive, the negative to the negative, and then attach a ground. One other thing that's important about DMX is if you have a lot of devices that are connected all in one chain, there is a possibility for the DMX signal to ring at the end of the line. So basically, on any piece of wire where you've got a digital signal that's imposed there, that signal can actually bounce back at the end of the wire and cause some interference in the fixtures. So if you've got a long chain of DMX fixtures, it's advisable to add a terminator. You can buy a terminator, on Amazon or eBay, or you can build one. It's just simply 120 ohm half watt resistor that's wired between that positive and negative pins on your XLR cable. So all of your fixtures, you can just connect them one right into the other, and they will all be on that same bus, and they'll all be receiving the DMX data. So to kind of show how that would look on a controller, and do I still have my screen shared here? I'll pull the chat up there. All right. Oh, and will this be same for a Lynx Express controller? So any controller, any Pixel controller that has a DMX out port, it should be labeled with a DMX positive, DMX negative, and ground. And so as long as you match up the pins on your XLR cable with the output on the controller itself, that will all work. So it's just positive to positive, negative to negative. That's all that you've got to do to make that adapter. So just showing how it looks on an actual controller. So this is the controller I'm using here. It's an AlphaPix. I just had it handy. You need to specify a universe that is going to be output to your DMX. So just like on your Pixel outputs, you have to specify a starting universe, number of channels, etc. You specify a universe that is going to be for DMX. And this universe needs to be dedicated. So you don't want to have any overlapping channels that could be spilling in from your Pixel data onto your DMX line. You need to have this set up as its own universe. It's a little bit different on each controller, but on the AlphaPix at least, it's pretty straightforward. So I have, for this demonstration, set up this controller at this IP 192.168.1.200 to have this DMX output 1 enabled, and it's going to be receiving E131 data at universe 10. So basically, this controller is acting like a bridge. E131 and ArtNet are both abstractions or additional layers that are built on top of DMX. So they are designed such that instead of having one cable for each universe, if we were limited to one universe coming out of our Pixel controllers, we'd only be able to control 170 pixels or so with the 512 channels that we have available. So the E131 and ArtNet, what they do is they encapsulate that DMX data onto a single Ethernet IP network so that we can send hundreds or even thousands of universes on the same wire. So uses Cat5 cable, not a 3 or 5 pin wire. Yeah. So on a Lynx Express, if you've got a Cat5, and the Falcon does as well. The Falcon has an RJ45 or Cat5 connector on it, and you just plug that connector in. That's what the manual is showing here. So on that Cat5 connector, just plug that in and wire up those colors to that output, plus and minus, and that's how you make your adapter cable. So that is the physical connection. Once you have your E131 data coming into your Pixel controller, coming out as DMX, now we have to take a look at wiring it all up in xLights. So what I want to do, I'm going to share a different camera with you. So this is, let's see. You guys can see that additional camera pointing outward there?
Yes.
All right, good deal. So I'm going to switch into xLights and basically show you from scratch how we would set all of this up, and then we'll get into some of the sequencing for DMX fixtures. So in this demonstration, I've got 6 RGB LED floodlights or wash lights that are along the base of the ground here, shining up onto the white brick. And then I've got 4 moving heads. These are a Beam 230. It's a Chinese knockoff of a clay packy Sharpie. And then I've got a fog machine down here, and I've got a snow machine hooked up. And one of the things that I start with when setting up DMX fixtures is thinking how they're all going to be connected. So you could have hundreds or thousands even of DMX fixtures in your display, and you really need to think about what's getting connected to what. So per universe, you're limited to those 500 channels, and different fixtures have different number of channels. So an RGB LED flood will have 3 channels for the red, green, and blue. Your moving heads, they could have 8 channels, 16 channels. Some of the higher end ones will have hundreds of channels per moving head. So a good place to start is to plan out what you want connected, how many channels it requires, and then that will help you start setting up your start channels in your universes. So one of the things that I do is I build a little spreadsheet here. So this is the spreadsheet that I built for this demonstration. All of these devices are all connected with the same DMX cabling. They're all in the same universe. And I put in how many channels I have for each one. And if I just do a little math here, I mean, I know it's going to fit in one universe, but we can verify it here. Each of these RGB LED wash lights requires 3 DMX channels. My 4 moving heads require 16 channels apiece. Smoke machine requires 1 channel. The snow machine requires 2. So I've got 85 channels of stuff that I need to put into a DMX universe. Since 85 channels is fewer than 512, I can just connect them all together. And as long as the start channels don't overlap, it's all going to work. So the start channel, like we discussed with the bus topology, the start channel is the channel on that DMX universe that fixture is going to listen to. So I could set up all of these RGB LED washes to start on the same channel. I could have 2 or 5 or 10 lights that I want to do all the same thing all the time and just set them at the same start channel and be done with it. But if I want to have them do different things, they have to have unique start channels. And this is the start channel for the fixture itself. And I want to make that very clear. We'll kind of explain the difference in xLights here in a second. But each DMX fixture will have a setting where its start channel can be adjusted. So what I've done is on these 6 RGB LED floodlights that are on the ground here, I have already set their start channels to 1, 4, 7, 10, 13, and 16, which are a contiguous block of channels going from 1 to 18. And I left some space in there. So see my movers, I started them at 101. I left some space after the RGB LED washes in case I wanted to add some more. You don't have to do this. You could just pack them in as tight as you want. There's no right or wrong answer. But for me personally, I like to keep the type of fixture in sort of a group here and then leave some space to add on. So I started the movers at channel 101, and each of them takes 16 channels. So the first mover is using channels 101 through 116, 117, 133, 149, etc. So once I've got this map, this is what I'm going to use to build it all in xLights. And you could do this, you could have everything in your display be a DMX fixture and use no pixels or no other devices whatsoever. It could all be DMX, or you could mix this in with other devices in your show. So in this example, it's all going to be DMX, but that doesn't mean that it can be different for yours. So starting from scratch in xLights. So since this is going through a pixel controller, I have to add my pixel controller here in the setup tab. You could also use DMX through USB. So if you have a USB to RS485 adapter, you can just plug that straight into your computer and use it that way. But since I run my show typically on a Pi player, everything's connected on an Ethernet network, and so all of the controllers are going to be E131. I'll also show here a demo later of how to do this through ArtNet, but we'll just set it up here to start with. So that controller lives at 192.168.1.200. And remember, on the controller, we set our DMX universe as 10. So all of the fixtures, they don't care what universe it is. They're just going to listen to whatever's coming out that port. But I still have to tell xLights that this is in universe 10. So 192.168.1.200, universe 10. We've got one universe. We're going to set it as one output, and we're going to create it there. And I will show you how to build a couple of fixtures, and then I'm going to switch to a layout where they're already done just so it doesn't take too much time. But you can build the models really however you'd like. For the floods or the washes, it's pretty simple to do as a single line model. We've got 6 of them there, and I'll make them a little bit bigger so that we can see them. So there's my 6 washes on the wall, and I'm going to set my my start channel here. I'm going to pick universe 10 and start channel 1. So again, back on my spreadsheet, my wash lights are channels 1 through 18. So it's going to start on channel 1. And since I've got 6 of them, it's going to build that automatically here. And I'll rename it here. We'll call these RGB LED washes. All right. So now we've got these RGB LED washes on universe 10, channel 1 through 18. Now, just to kind of show that this works, I can go in here and make a new sequence real quick. Put my washes up there, and we'll do a little bars effect, output to lights, and we've got, let's move it to the right here. So now you can see the lights are going with the sequence. So that was pretty easy. So I'll add a moving head and show how that works. So we put a moving head in here. All right. And this is a little bit trickier. We have to actually specify what the channels do so that the model looks correct. Now, this stuff in here, the pan channel, pan orientation, all of this only matters as far as the preview is concerned here in xLights. This does not affect how it's actually going to look on the sequence, with the exception of the color channel. So if you have a moving head that has separate channels for individual colors, you can actually use an effect like bars or something that is color aware, and it will map that color to the correct channel. On these moving heads that I'm using, we have color wheels and not individual LEDs for the color mixing. So these colors don't really affect anything as far as the sequence is concerned. So I set this up with 16 channels, and I will put in my start channel here. So these are on universe 10, and let's go back here. So mover 1 starts at channel 101. So start channel 101 on universe 10. There we go. And one of the other things to keep in mind if you want your model preview to match what it's actually doing is this pan orientation, pan degrees of rotation, and then tilt orientation, tilt degrees of rotation, etc. On these moving heads, and let me get into the sequencer so I can show you what they actually look like. We'll get rid of that, make a new one. Okay. So I'm going to breeze through this real quick and go into it in some more detail here later. I just want to show you, well, we'll go back to the layout. So that is adding one fixture, and I'm going to switch to the layout where all of the fixtures are already in here. All right. Okay. So what I did, and I skipped over it in this demo here, but what I have done is I've adjusted the pan orientation of this model here so that it matches the actual direction that the fixture is pointing. So I'll show you what that means when I actually apply an effect to it. So this DMX effect and strobe. And 200 layout. And got a question here. What was that? Oh, oops. Thank you. Let's see here. I think my output to lights is on. This bar won't go away. Oop. Need to move my zoom bar. There we go. There we go. Thank you. I thought it was clicked. I thought when it was yellow, it was on there. So okay, thank you. So what I was breezing through really quick is that to make the pan actually mirror what is happening on the fixture, I had to adjust the rotation 180 degrees. Oh, and I'm actually now just seeing my camera. My external camera is reversed here. Let me switch which camera you guys are seeing. Yeah, sure. I'll get you a link for that. So my video, let's see. So is that a zoom setting where this camera is flipping left to right? It's flipping horizontally. I just want to make sure physically this moving head that you guys are seeing, this is on the left side, but it's showing on the right side in my camera preview. So I didn't want that to, it shows on the left side. Okay, well, let's just zoom then. Sorry about that. I tested this for myself, but I didn't have this little inset camera window on here. So it just looks different, but it's just zoom. Okay, so again, what I was explaining there in the layout tab is that to get the fixture to match what it's actually doing, that's where these settings come into play. So the default pan orientation is 0 here. So if I set that back to 0, you can see on the model preview, when I'm adjusting this pan channel, the model is looking like it's rotating counterclockwise, but the actual moving head, I'm sorry, it looks like it's rotating from the right up to the left. So it would show that it's pointing to the right now, but the fixture is actually pointing to the left. So to correct that and to make the model match what the actual fixture is doing, that's where this setting comes into play. So the pan channel, that maps the effect to the way that it's rendered on the screen for the preview. So again, because this fixture actually does pan with channel 10, if I put channel 10 here as the pan channel, it's going to match. And that's one of the things that I have pulled up. Oh, sorry, different sheet. So a good moving head, when you purchase it or when you are looking at it online, it's going to have a document that is going to show you what all of the channels are for that. So this is the Alpha Beam 700 instruction manual, and down here, somewhere in the middle, it's going to give you a little breakout of what each channel actually does. So here we go. So channel 1 on the clay packy is the cyan color filter, channel 2 magenta color filter, etc. So the pan would be channel 16. So if this were a clay packy fixture and I wanted my model in xLights to actually match what the physical fixture is doing, I would set that pan channel in my xLights model to 16, and then they would match. These fixtures that I'm showing, these Beam 230 fixtures that are a Claypaky Sharpie knockoff, they didn't come with a great description of what their channels did. So I had to go through and build a channel map for myself, and then saved it here in this spreadsheet so that I could reference it and more easily program and sequence the fixtures. So this is just through trial and error, going through each channel and in test mode and adjusting the ramp from 0 to 255. These are the ranges that affect this fixture. So channel 1 is the color wheel, and I put some values here for, you know, what value produces what color. Channel 2 is the strobe or the dimmer, etc. And so I have filled in this information in xLights so that the model that it shows in the preview is as accurate as possible. Again, none of this actually matters for how it's going to look in a display. It's only going to matter for how good your preview looks. You could do all of this with just single channel models, channel block models or single line models, as long as you knew yourself what the channels were. But it's helpful to put this stuff in and make it correct so that it's easier to sequence. One of the other things that is also very helpful is in the strand and node names to put in what the actual function of each channel is. So these node names, that corresponds to the DMX channel that is actually on the fixture. So what I did for this Chinese fixture, Claypaky Sharpie knockoff, is I transposed all of this information. So channel 1 is the color, channel 2 is a strobe, etc. And what that does for you is when you are sequencing and you drop a DMX effect onto one of those heads, these sliders over here are now labeled. So by default, if I had not put in those node names in there, this would just say channel 1, channel 2, channel 3. But by putting that information in here, it's now much easier to understand what's actually going on versus having to keep, you know, going back and forth to my spreadsheet and saying, okay, channel 1 is this. Just as an example, and I'll get into this a little bit more, when you put moving heads in a group, the names do not transfer from the individual model level up to the group. So this is what you would see when you're sequencing at a group level. And this is also what you would see at the individual model level had you not put in those names for the individual channels. So, all right, now that we have our models in here, we've assigned the number of channels. We have made our model match the correct orientation, put in our pan channel, our tilt channel. Another useful channel that you can have in here is a shutter channel. So the animation for the fixture preview will actually hide and show this beam that's coming out here. It works the same in 2D or 3D. You'll see a little beam emanating from the fixture, and that will come and go based on the value of this channel. So if the shutter is turned down to 0, that beam will be completely gone. And then this shutter open threshold, that's basically saying, okay, above what level do I start drawing this beam out here? So again, all of this only matters for the preview and visualizing it before you actually see it on your display. What I find is if you're doing moving head work, it's great to just get them hooked up and play with it, because it's really hard to visualize sometimes if your moving head doesn't use LEDs as a light source. If it's just using a color wheel, it's hard to visualize, okay, what is the actual color of this channel value? What's it going to look like? So it's good to just have it all plugged in and play with it. One of the other things here in the models that I've done is I have submodeled the dimmer. So when you start working with moving heads, there's a couple of idiosyncrasies with sequencing them in groups. certain effects don't work on moving heads in groups the way you would think they would, and doing things like having multiple heads turning on and off. Let's say that you wanted to have some kind of a bars effect with the moving heads, where you wanted the first one to turn on and then the second one to turn on, third one to turn on, the first one turns off, etc. You could do that manually at the moving head level, or with adding a submodel to the model and then putting those submodels in a group. You can do some kind of unique things with that too. So we'll take a look at the sequencer here and just start playing with some of this stuff. So the most of your moving heads will have a lot of different ways that they can be programmed, and it's good to just start playing around with some of this stuff. So on a lot of them, what you'll find is to get the light to even come on, it might take more than one channel of control. So on this fixture, and I'll turn it around just so we can see it a little bit better. So on this fixture, what you might think would turn the light on just by turning the dimmer up actually doesn't do anything on its own. So a lot of fixtures will require some kind of a shutter or a strobe channel to have a positive value before the fixture will do anything. And we can go back and look at the spreadsheet and kind of see what it does. So when the strobe channel is at a value of 0, it's going to be off. A value of between 1 and 50, it's going to be on. And then values between 50 and 240 are going to actually strobe the fixture. So if I put my dimmer at 100% and put this somewhere, in that range there of 50 to 51 to 240, it's going to start strobing, and it's going to be, slow to fast, etc. So I can just turn that up. The color is going to be defined by that color wheel. And again, this is just something that is going to be different for each fixture. If the fixture does not use an LED light source, or if it does not have dichroic filters for full color mixing, you are just going to have to write down and remember which colors, which DMX values correspond to which colors. You can also use the state effect to preset some of those values. If you've got like a red or a green or a blue that you want to use, you can save that and then just call back that state. But I'm going to show you another way that I like to manage color and movement together. So we've got our color channel, our strobe channel, dimmer. The Gobo is one of the cool things that that most of your DMX fixtures will have, or your moving head fixtures will have. And I'm going to move it up here so we can see it a little bit on the wall. All right, so we've got it pointed up there on the wall. The Gobo is basically a piece of either glass or metal inside of the fixture. I'm going to hand it over a little bit to get a better spot and focus it here. Hopefully we can see the shape. There we go. All right, so there's a star shape that is coming from that Gobo. There's a smaller little triangle, full open. You've got all kinds of different little shapes, and these can be used in combination with the color. You can change the color. All of this stuff is additive, so you can add the color in with the Gobo. And this, again, every fixture is going to be different. So if you have a good fixture that has a good definition where you can look at all of this stuff, so like on the Clay Packy, it actually has pictures of what all of the individual Gobos look like. But on this Beam 230 fixture, we just got what we got. It might have pictures in the manual or pictures in the specifications, but really to find out what it's going to do, you'll just have to run through these different DMX values and see what you can do. So again, when I built this channel map, I kind of gave a little description what each channel range did. So if I want to go back and reference it, I can take a look at that. And Gobo is another acronym. It kind of an acronym. It stands for goes between or goes before optics. It's basically a piece of glass or piece of metal with that shape on it that is sitting in between the light source and the final focusing lens at the end of the fixture. So there's the Gobo. The Prism is another feature that a lot of moving heads have. And what it does is it will fracture the light, very similar to the kaleidoscope effect that is here in xLights now. So it will take the same shape and just kind of split it and multiply it across the surface. So this fixture has an 8-facet prism. That might be something that you would see in a description for a fixture is, it's got a 4-facet or a 6-facet or a 20-facet prism, or might have multiple prisms. That is what the prism does. It's going to take that same shape. If I've got that Gobo in there, I can take the Gobo out, or I can switch to a different Gobo. So there's a little tiny dot Gobo. Put the prism in, or put the prism out. And then a lot of the prisms will also have a rotation. So there are indexable values. If you had a prism, if you had a Gobo that had a particular shape that you were trying to align a certain way, you could index the prism to a certain value, or there's going to be a range here of this prism where it just rotates. So again, I can go back and reference my document here. Prism rotation between 0 and 127. Those are indexed positions, or between 128 and 191. That's going to have a counterclockwise rotation, fast to slow. So you can play with that stuff, and we can slow that down there. So now we've got a counterclockwise rotation that's going pretty slow with that prism. On this fixture, we've got this Gobo Bounce option. So we can actually make the Gobo itself twitch in there, and it can bounce up and down, give it a little bit more liveliness, animation. Gobo Bounce, I think that's a fast to slow as well. Yeah, so 1 to 191, it's going to be your bounce speed, fast to slow. And a lot of your fixtures will also have a frost or a wash option. So what that does is it just puts a piece of frosted glass right in front of everything else. So we can actually take the prism out, take the Gobo out, so it's not reducing the light beam. So we had this little tiny Gobo, which was constricting the beam to be very small. So when we put the frost on there with that small beam, now we've got a really small frost. If we take the Gobo out, now we've got a big beam, put the frost on there, now we've got a bigger area that we're washing. So the frost is kind of like converting a spotlight into a wash light. So take out the frost there. And the focus, a lot of your moving heads will have a focus adjustment. So let me put in a Gobo. This will be easier to see with some kind of a shape. So yeah, so right there, it's in focus at this distance. And I'll actually zoom in here with the camera and point it over a little bit so you can see that more specifically before we get into multiple heads going. So there, it's pretty bright, so I'm going to turn it down so it's not over saturating the camera. Okay, so that right there is about in focus for this distance. If I take that focus all the way down, you can see the shape is totally changed because the fixture is not properly focused for the length that it's projecting onto. So this will be, dependent on your situation. Some moving heads have an automatic focus where as you move it from one place to another, or as you zoom in and out, it will actually autofocus for you, just like a camera will, but most of your lower end stuff is all going to be manually focused. So if you're using a Gobo and you shine it up onto a surface, you think, oh, this has got a cool shape but it's, it's not looking like how you want it. You probably need to take a look at the focus so that gobo is visible. And then we've got our pan channel. I'm just going to move it side to side. And in xLights, your channels are grouped in, I think it's 10 here. Yeah, we've got 10 channels per little tab up here. And so your first 10 channels are going to be on the first tab here, your next 10 channels, etc. If you've got a model that uses more than 40 channels, there's a lot of Beam 230s out there. If you've got a model that uses more than 40 channels, if you've got a fixture that uses more than 40 channels, you'll have to build more than one model to accommodate that. And this used to be even smaller. I think Gil updated this here a year or so ago to add more channels to this effect. So you've got typically a pan and a pan fine. So the pan fine is a very, very small movement. If you want to get really, really detailed and really close into, putting something precisely in a particular spot, you can use your fine adjustment. Tilt is the same way. You've got a tilt and then a fine tilt. The speed, a lot of fixtures will have a travel speed where you can actually adjust how quickly it moves from one position to the other. By default, it's going to move as fast as it physically can. And then if for some reason you want to slow that down, you can adjust that speed. So this is an inverse relationship here. 0 is full speed and then 255 is going to be slow. A lot of fixtures will also have some extra channels that are kind of like management or configuration channels. On this moving head, channel number 15 is a reset. So if you were, and we typically wouldn't use this for xLights in a Christmas show, but you might if you've got a long running show or you just want to reset your fixtures. This channel has a specific procedure that has to be done to reset the position. So you've got to take it from 0 to 255 and hold it there at that value for 5 seconds, and then the fixture will reset itself. And what that is actually doing is it is moving it back to its home position. So it's going to rotate all the way around. It's going to tilt all the way down and make sure that its encoders know that it's at the correct position. So it uses little wheels with a little infrared pulsar that is constantly monitoring the angle of the fixture. And if that angle gets off for one reason or another, it gets bumped or, there was something in one of the gears, that position could get off and it would need to be reset. So that is some of the basics of the movers. What I really wanted to get into is some of the tips and tricks for how to sequence them. So when we've got one moving head like this, obviously we can build different looks with this moving head and then just kind of transition from one look to another. But most people that want to put moving heads in their show, they want to put them there because they move. And we accomplish that movement by manipulating the value curves. So all of these individual channel values can all have a value curve applied to them. And what you would typically be working with would be something like your pan and your tilt channels. So to take, let's say that we wanted the fixture to rotate around, halfway or so. And we'll just start by finding a good position here where we want it to start at. So let's say, all right, it's pointing to the left. We want it to go from the left to the right. And this is a good time to bring up the fact that most of your moving heads will have a greater than 360 degree range of motion. So these have a 540 degree range of motion on their pan channel. So the 0 to 255 DMX value actually corresponds to 1.5 times rotation around the base. And oops, I did not zoom the camera back out so you guys can see all of them. All right. Sorry about that. Okay. So most of them will have a greater than 360 rotations. So playing with the pan here, if we wanted it to go from left to right, we see that we want it to sweep through a value of 0 to about 85. And you can do the math on this as well. I usually have a little spreadsheet pulled open that is going to correlate the DMX value to a rotation angle, and it's a fairly simple formula to figure it out. But you can also just look at it and see, okay, does this look like what I'm trying to do? So if we know that we want it to go from 0 to 85, we can apply a value curve on here, and we'll use a ramp, for example. So 0 to 85. So now in this time slot here, this effect, we can make it, make it 10 seconds long or so. In that 10 seconds, that head is going to rotate around 180 degrees. And I'll tilt it down here so that we can actually see it a bit more as it rotates. And it's going to rotate through that 180 degrees. One thing to keep in mind with any DMX movement is there is a physical limitation to how fast they can move, and that is the slew rate, which you can specify it in your model, and it's also a physical limitation of the fixture. So if you plug that value in to xLights, it will only draw the model as fast as the fixture can actually move. And what will happen if we try to tell the fixture to move faster than what it actually can, it will jump. So it won't actually get to the final position before it kind of resets and goes back to its original position. So if we use a sawtooth, for example, and we say 0 to 85, and we want to do 4 cycles. So it's going to move left and right, left and right, left and right. The problem is, if you can see the fixture, it's not actually going all the way left to right, because we are trying to tell it that the DMX values that are being sent out are faster than what the fixture can actually move. So it's not moving through its full range of motion. It's getting that value, it's trying to move to that position, but it just can't move fast enough, so it's getting stuck. If we take that same effect and stretch it out longer, we can see now it's actually moving through its full 180 degrees of rotation that we told it to, because our ramp there, our value curve is within its slew limit. So something to keep in mind when you're sequencing those. So what I like to do in sequencing a moving head is to build an effect for one head, and then apply that to a group and manipulate it from within a group. So if we've got this one moving head that we want to move left and right in this position, I've got this effect here. I can move that effect up into the all movers group. The problem with that is the render style is not going to be correct for a moving head. You want the values of that DMX effect to apply the same value to all of the models, not to do any manipulation in the render buffer. So we have to change the render style to a per model, either per model default, per model per preview. Any of the per model rendering styles will work for controlling multiple moving heads. And there we go. So now all 4 of them are doing the same thing. And I'm going to go turn the lights off so you can see it a little bit better. I'll be right back. Okay. So they're all moving around. If we wanted to have them all moving, but we wanted to change how the light was looking out of each fixture. So let's say we wanted them all to have the same kind of motion, but we wanted to do something different with the color. We want one of them to be red, we want one of them to be blue, etc. A good way to do that is to use layers and use a layer blending style. And I don't have my, let's see. Yeah. To use a layer blending style of additives. So what we can do is I've got this movement that I want all of these fixtures to do. I'm going to separate the movements from the color. So if I take this effect here, which has this color of 0, which is going to be the white, if I take that and apply it to that group, they're all going to be white. But if I only apply the movement channel values to that group, then I could apply a color value or some other value to each individual fixture and achieve a different look. So in this group here, where I've sequenced it at the group level, I know that I'm going to move it down just so it's clearer which channel I'm manipulating. I know that my color channel is currently set at 0. So if I put that effect back in there at the group level, now I add another effect onto one of these models. If I change the layer blending to additive, what that's going to do, I need to reset all this stuff to 0. What that's going to do is it's going to take the DMX values from the effect that's at the group level, which is the movement that I want. It's going to apply that, and then these effects here that are at the individual fixture level, it's going to add those DMX values. So since we've got the movements and the gobo and the focus, all of that set on the effect that's here at the group level, I could change just the color per se on this one. So if I want this one, let's go look at our color chart here. I'll just pick one. So we want it to be red. So a range of 8 to 11 is going to be red. So I can put that there. So now that first head is red and the rest of them are white. I could take that effect and duplicate it, put those in different movers, and I could change this value. And let's pick another. Yeah, so there's a half green. Pick one over here. There. So now we've got 4 different heads that are all sharing the same movement, but they've got different colors because of the way that we manipulated the layer blending. So the DMX effect really lends itself to using an additive layer blending like that, where if you want to have a movement be defined by one layer and then add on the additional effects like color or gobo or something like that in another layer, or add it to the fixture level. So if we wanted to add an effect, wanted to change the color on all of the fixtures while we were maintaining that movement, now all of the fixtures are going to be white. We can duplicate this effect, put it over here, and we'll change it to red, something like that. So now, as it's playing, whoops, hang on, 0. Oh, they're the same. Okay. What did we have? 8. Oh, here we go. My render style was not correct. There we go. So again, when you're at the group level, this is something that'll get you every time. When you're sequencing moving heads at the group level, you have to make sure that the render style is a per model default, and that's going to be for every effect that you're trying to do at the group level. That will throw you off every time. So we've got a movement in one layer, we've got a color in a different layer, and that's how we can sequence our moving heads. You can use that in combination with, with different value curves to try and get cool looking effects. So if you want to have, beams that intersect and draw certain shapes out in the sky, it's all just with value curves on those pan and tilt channels. And you can, get creative and just play around with it and see what looks good. But it's all just using the DMX effect. One of the other things that I'll show you with the using layers on the DMX effect is that submodeling that I did. So I'm going to move this down so I can see what it was doing again. All right, so the dimmer, we've got the dimmer down low here, and I made that submodel for all of the different dimmers. So what I'm going to do is I'm going to turn that dimmer all the way down and then put this there back at the group level. So that's going to be our motion that these lights are going to have. And I got to change that back. All right, so now they're going to move, but they're not lighting up yet. So if I wanted to have them all light up in a pattern per se, I can put this bars effect down on my dimmers. And now I got to put a black in there too. All right. So now you can see what's happening is the bars effect is working just on the dimmers, and it is going to turn the lights on just as you would, with the pixel. But because the DMX effect is not aware of a lot of these, a DMX model is not aware of a lot of these other effects. It really helps to submodel certain channels like that you want to behave like single channel models or like pixels. So if you had a fixture that had an RGB light engine, like an LED light source, you could use one of these color aware effects and actually change the color with these as well. Okay. So those are the moving heads. Any DMX fixture can be controlled with this DMX effect, or if you submodel it correctly, you can use other effects as well. So we can put in something like our smoke. So the smoke machine, it's just a single channel 301 on Universe 10. And if we want our smoke to trigger at a certain time, we can just put a DMX effect in here, and then either set it to a particular smoke intensity at that time, or we could use a value curve for that as well. So if we want the smoke to ramp up over time, we can just put that in there, and just like that, we've got, triggerable smoke effect as well. So any fixture, any prop, any of the thousands of different things that are out there for theatrical displays, in stage productions and movies, anything that's DMX controllable you can control in xLights with the DMX output on your controller and the DMX effect. So we've got the smoke machine, that's just a single channel. The snow machine actually has 2 channels that affect its output. So again, this is the manual for the snow machine. Any good DMX fixture is going to come with a manual that gives you a description of exactly what it does. So for the snow machine, channel 1 is going to be the snow output. So 0 to 5, it's not going to do anything. 6 to 255, that's going to be your snow. Channel 2 is going to be the fan. And this particular device, it won't work unless both channels have a value. So that's just something that each device is going to be a little bit different. You've got to either read about it or just play with it to see how it works. But we can, since we've set it up with its start channel of 401, it's going to be listening to channels 401 and 402 to decide what it's going to do. So if we take that effect, put it down there on, on our snow machine, not our washes, and we turn up our snow output and our fan, now we've got some snow. So any cool theatrical effect that's DMX triggerable, confetti cannon, movement on a fountain, anything that you can control with DMX, you can control with xLights. And these DMX wall washes, since these are 3 channels and operate just like pixels, we can put in, take out some of those other effects. We can put in there we go. We can put in a bars effect, or we could put in a butterfly effect, since these things are regular 3-channel models and they're color aware. Any of these effects that use color are just going to automatically work. So yeah, there was another thing that I'd like to show specifically on moving heads, and I'm running a little bit long on time. I guess I can open it up for questions, and if people are interested, I've got one that's completely torn apart here that I can point out.
You're fine on time, so
okay,
you need to go.
All right,
extend it. Go ahead.
Let me turn the lights back on here, and then I'll zoom in on a moving head and show you kind of some of the different components and how they all work together to make the whole thing work. So give me just a second. I'll flip the lights back on. Be right back. Okay. All right, so I'm going to move my camera for you guys and focus in on this guy. So, all right. This is a Claypacky brand Alpha Beam 700 fixture that is all taken apart. So this is the inside of the fixture with all of the housing removed. And just for reference here, there is, there's one that's all put together.
You should stop screen sharing so we can see that.
Oh, sorry. Here, let me zoom bar go. Zoom. My bar has disappeared. Oh, there it goes. Stop share.
Thank you.
All right. So there's one that's all taken apart, and basically there are a couple of components that are common to every moving head, regardless of brand and cost. So they're all going to have a base that is going to contain a pan motor. So again, the moving head, this one can rotate around 540 degrees. So there's a motor in the base that's rotating it. There's also a transformer and a ballast in here. This moving head uses a discharge lamp, so an arc style lamp for its light source. And that's kind of a question that I've gotten from several different people on, does this moving head, is this going to work good for my application? What is this going to look like? If you are trying to make a beam in the sky, a visible beam, then you really need a light source that is well collimated and is well, it's got a very fine beam angle. So one of the problems in optics is to get a beam that is very tight, you have to start with a very, very small light source. It's difficult when you have a light source that is physically large to get all of those photons all lined up perfectly straight so that they head out the lens and don't start diverging in space. So a lot of the high-powered fixtures that make really nice tight beams in the sky will use a discharge lamp light source. Now, there are some fixtures that use LED light sources that can make a $9,000. Yeah. So these fixtures are very high end, but I did not buy them all new. This stuff you can find used all the time from different stage productions, and that's where I get them. So you can get these things that are a year or two old in great condition, and even $2,000 for a used one. I paid less than $1,000 for each of these, and to say I didn't pay for that. The show that I put together, they pay for that stuff. But there's a lot of used equipment out there, and getting in touch with some of the distributors and production companies, you can find it. But anyway, the LED light sources, as the output of individual LEDs continues to get better, you will start to see more of these fixtures be available with LED light engines. But for now, to get the ultimate in a tight beam look, it's going to have a discharge lamp. So if you want a moving head in your display that's going to have a visible beam in the sky, you're going to want something that has a discharge lamp. And apart from the lamp, most of the quality in a fixture is going to come from the reflector and the lens. So this fixture has actually had the reflector removed because that was what went wrong with this one. Is a bulb went out and actually exploded, and so it took out the reflector with it. But the reflector would sit right here in between this base, which holds the lamp, and this first lens right here that it passes through. So this is an IR and a UV cut lens. So this is going to take out as much of the IR and the UV as possible so that it's not as damaging to look at, and it's not going to wear out anything that it is shining onto. And these modules all go in between the light source and the lens out here at the end. So this module is the first thing that the light goes through on its way out of the fixture. And on this fixture, this has full color mixing. So even though the light source is a white light, we can use these dichroic filters to change the color of that light. So each of these dichroic filters is going to remove, this is a subtractive light mixing. So each of the filters is going to remove certain frequencies of the light from the white to cut it back down. So, white light contains all of the colors. And then if we cut out the red and cut out the blue, we're going to be left with the yellow. And that's what these dichroic filters do. As you mix these, as you put them in and out of the light path, it's going to remove different frequency ranges and change the color. There's also, just like those fixtures that we were using earlier, a color wheel. So any of your fixtures that have fixed colors available, this is how it actually works. There is a physical wheel that has these pieces of dichroic glass in here, and they are indexed with this little encoder on here and a little servo motor to certain positions. So if we want to make a blue or a yellow or a red, that DMX value that we were looking at corresponds with one of these color wheel positions. So that's literally how it's working. It is moving that color in and out of the beam path, and then everything beyond there is going to be that color. So this is the first thing that the light goes through on its way out of the fixture. And then this is the next thing. So this assembly is where all of our Gobos are. So this fixture has more Gobos than the one that we were looking at earlier, but this wheel right here has glass Gobos that can be put into the beam. And they also, if you can see that, in addition to changing the Gobo itself can also rotate. So we were looking at the Prism, the actual example of the Prism with the Beam 230s. They had a rotating Prism, but this fixture actually has rotating Gobos. So if you got a shape in there, you can rotate the shape itself. And then they all will have an open hole where just the light can pass through, because, you know, if you didn't want to mix two Gobos together, you've got to have a way for the light to get out. So this wheel here that I'm rotating, that's the fixed Gobo wheel. So if we didn't want one of the rotating Gobos in the beam path, we just wanted a fixed Gobo, we could index that, move that right along. And then the next thing that it's going to go through is the Prism. So, this little thing that I'm sliding in and out, and we can get a better view of it from the front. This is the Prism. So it looks kind of like a kaleidoscope, or the kaleidoscope effect if you played with it, because that's exactly how it works. It's going to take the same image and split it up. In this case, this is a 6-facet prism. It's going to split it up into 6 pieces. And that prism also, just like the other one, it rotates. So, you know, you can have the prism inserted, and then you can rotate it while it's in there. And then there's our white glass, which is our frost filter. That's how we change that narrow beam into more of a wash. One thing that's a little bit tough to see in here is that this whole assembly actually moves forward and backwards in the fixture. So that's how it accomplishes the focus, is it's changing the distance that the light has to travel before it exits out the final lens. So there's a Fresnel lens there at the end. That's what collimates all the light and makes it as narrow of a beam as possible. This piece right here is typically called the yoke, because it rotates on the base with your pan, and then it has a motor in it as well. This one's got a locking mechanism on it, so you can lock it into place if you're doing some work on it. But it would tilt back and forth like that. And your high-end fixtures, are very easy to repair, because they're designed to be out in the field for weeks or months at a time. So this is one of the difference between a clay packy or a Martin or something like that versus one of the Chinese knockoffs. I mean, these fixtures, everything's on little pluggable connectors. There's just a couple of screws. I mean, you could take apart, put this thing together in 5 minutes if you had to. Very easy to work on. A lot of diagnostic features as well. It'll tell you when something's gone wrong. And they shut down if you've got an overheat or a bad sensor, something like that. One of the other cool features on a lot of moving heads is a DMX pass-through. So you could actually have this fixture be connected to an IP network running on ArtNet, these fixtures will ingest ArtNet directly. So you don't have to run them through the DMX port of your controller. You could send ArtNet straight to the fixture, and you can actually daisy chain additional fixtures off of that one by using a DMX out capability. So yeah, that's a fixture torn apart, kind of how it works. And yeah, I guess I can open it up to questions.
So feel free to mute yourself and ask any questions you'd like.
I can switch back into xLights too if you've got any questions on
Hey, Lee.
how to sequence stuff. Yeah.
Hey, I got a question. I purchased 4 moving heads earlier this year and just kind of playing with them. And I just want to verify that I have like model data set up. I kind of came in at the last part when you were doing a little demonstration on, making them active and everything through xLights, but
Sure.
I don't know if you touched on the configuration side.
Yeah, so I'll go back to sharing the screen here. So the model, really the only thing that is, I shouldn't say the only thing, the most important thing on the model is just getting the number of channels correct, because that is what's going to actually populate those sliders when you go into your sequencer and start working with the DMX effect. So yeah, as long as the number of channels is correct and the start channel is correct, you can control that prop and do anything with it. Whether or not the preview looks accurate to what the fixture is actually doing, that's a total separate thing. That's where a lot of this data comes in. So
yeah, so the ones that I purchased were 16 channel.
Yep.
So I had the 16 channels entered into the model data. So your pan channel orientation and all that stuff is not, does it matter?
It doesn't matter for actually sequencing. It matters for how the preview is going to look on the screen.
Okay, so as long as I select, like on the, I don't know which little dialog box it is, it gives, let's see, on the effect right there, whenever you have your 16 channel, you can go and select each one. As long as you're telling it what the manual tells you what the presets are built into the fixture, it's going to do what these presets are. That's
correct. Right. Yep.
And that's just going to be the DMX data that's pushing out to the fixture, right?
Correct. Yeah, and that's you might have missed the part where I went into the node names. So this is where this is very helpful when you're sequencing.
Yeah, I was digging around. I'm gonna go make some adjustments on mine.
Yeah. So like these Beam 230 fixtures, I built this spreadsheet myself just from trial and error by going through each channel one at a time and then writing down what values did what. And then I took these channel descriptions and then plugged them into xLights in the node names. That way, when I am actually sequencing,
you get more of a realistic, as long as you're hitting your channel count from 0 to 255 on each channel output, the
value, the DMX value, as long as that DMX value is
corresponding to what is the default settings are inside the fixture.
Yep. Yeah. So as long as this channel that we've got set up here for this model, as long as this start channel and the number of channels is correct, none of the rest of this really even matters. This is going to be channel 1.
It's just a visualization in the preview, right?
That's right. It's the visualization in the model preview, and then it's helpful, here to see what you're actually doing. And there is, I go back a little bit. The color channels do something. So if you do put the red, green, and blue channel in here for a fixture that can do color mixing, like an LED fixture, then that will affect the way that you can sequence it, because you can just drop a color onto that model and it will respect that. But a lot of the fixtures are
not.
Yeah, a lot of the fixtures don't have color mixing, and even some of them that do have color mixing, those channels might not correspond. So like if you've got a fixture that is using a CMYK color wheel as opposed to an RGB color wheel, and it doesn't have an internal way to flip that, then those values are all going to be inverted. So, you know, it all depends on the fixture as to whether or not that functionality will be of use at all.
Okay. And then as far as the like driving directly, like out of a serial output on a Falcon.
Yep.
I know I've seen a couple of videos where you have to make like a little cable to go that you plug into your, you know, convert over to an XLR.
Yep. Yeah. So it's pretty straightforward. You just have to match the positive to the positive, the negative to the negative, and then wire it up to the RJ45 or the Cat5 connector in that order. So there's a page on the Falcon manual that, you know, this page here describes exactly how to do it with the different ports.
Okay, yeah, because I purchased a XLR to Cat5, just an adapter.
Yep.
And I'm not sure how that is wired internally, if it's going to mate up to what we need it.
Exactly. Yeah.
And I think that's my issue, why I can't get the light to talk out of xLights. I was going to go build me a custom cable based off of, you know, this information here.
Yeah, this is a standard, but one of the things that you might find, and I've found with some of these fixtures, is some of the manufacturers don't use the standard. You might have the plus and minus reversed or something swapped with the ground. So you really have to check the fixture. If the fixture is, you know, a higher quality, domestic produced, it's going to be standardized, but and it's going to be labeled. So, you know, I'll switch back to.
Yeah, unfortunately, I don't have the funds to buy that as a hobby.
Sure, no, that's.
So I went with some 350 watt 17R, like, you know, knockoffs.
So this fixture, and might not even be close enough to see it yet. Let me pop my camera off. So a lot of your fixtures will be
focus.
Yeah,
focus.
Come on. There we go. A lot of your fixtures will have a description right next to the port.
Okay, your DMX, what your pinouts are?
Exactly. Yep. And that is the standard right there, where you've got your number 2 pin is your minus, your number 3 pin is your positive. Yep.
Okay, are there any final questions for Lee?
So Lee, do you put these moving heads out in your yard for 6 weeks and let the weather have at them?
So no, these all go into, these particular ones, the clay packies, they all go into a commercial display where they get, we have not bought domes for them yet. We might do that this year, but they get covered up every night. We basically have, they're sitting on cinder blocks, so they're off the ground. And then we have trash cans that go over top of them at night. And then if the weather is bad, you know, we'll just leave them covered. But typically, you know, we don't get rain or anything in the wintertime. We might get a little bit of snow here in Kansas, and they work just fine in the cold, as long as they aren't started and stopped quickly before the lamp has time to cool. But we do protect them overnight and then keep them off if it's going to be bad weather.
Yeah, that was my next question, is how temperature sensitive are they to the ambient?
Yeah, so it's really more about condensation than anything. The temperature range, the acceptable temperature range, is pretty wide on these things. They can run, you know, down below freezing as long as there is no condensation being formed. So if it's, you know, really cold and then it's a little bit warmer and gets humid and forms condensation inside, then that's what's going to damage the fixtures.
Okay. Anyone else?
Oh yeah, there's a good comment in the chat about DMX1. Yes, it doesn't have the ground. The ground is good, but most of the time, your fixtures will work without the ground. It's really, if you're in a situation where you've got a lot of noise on the line, or you're really pushing the distance on these things where you need a drain on a real DMX cable, a conforming, to spec DMX cable. It will be shielded, and that ground will be used as a signal drain to remove interference from the line. So, for most of your applications, using port 1 is going to be okay on a Falcon, but if you are pushing the limits, probably should use one of the other ports so that you can connect that ground as well.
Well, Lee, I want to thank you very much for an excellent presentation. Learned quite a lot.
The xLights project exists because of people like you. Help continue the project by making a donation today at xlights.org/donate.